Hi everyone, this is AKD Saw with you in the channel Classes with I Learn. So let us continue today with our topic, the stoichiometry part 2, and today we'll do the problems based on the weight volume and the volume relationship. So the first question is 2.50 gram of a sample of sodium bicarbonate when strongly heated gives 310 cc of carbon dioxide measured at 27 degrees Celsius and 760 millimeter of pressure, means mercury pressure. Calculate the percentage purity of the cell. That is the sample, its percentage purity. So you know the reaction is 2NaHCO3, sodium bicarbonate, strongly heated, and this produces sodium carbonate Na2CO3 plus carbon dioxide, the gaseous state, and plus water. This is a vapor state, you know. And the carbon dioxide that which is produced according to the concept of mole, you know, it will be 22,400 milliliter at NTP. And if you add this, the molecular weight of 2 moles of sodium, you know, bicarbonate, it will be 2 into 23 sodium plus 1 hydrogen plus carbon is 12, and for 3 oxygen is 48. So summed up together it is 168 gram. Okay. So you see 168 gram of sodium bicarbonate is producing 22,400 milliliter at NTP of carbon dioxide. So naturally, by the unitary method, you know, from 2.5 grams of sodium bicarbonate, carbon dioxide that will be evolved should be this 22,400 into 2.5 upon 160 ml at NTP. Therefore, from the gas law formula, this should have a volume at 27 degrees Celsius, that is 273 plus 27, that equals to 300 Kelvin, as 22,400 into 2.5 upon 160 into 273, and this equals to V by 300. We are utilizing the formula V1 by T1 equals to V2 by T2. Therefore, you get that V is equal to 366.3 milliliter. But the actual volume of CO2 at that condition, it is given 310 milliliter. So the purity of the sample would be 310 upon 366.3 into 100, and that amounts to 84.63%. That is, the purity of the sample is 84.63%. Okay. So let us press another question in this regard. Calculate the weight of MnO2, manganese dioxide, and to the volume of the hydrochloric acid of specific gravity 1.12 containing 40% HCl by weight needed to produce 1.78 liters of chlorine gas at STP according to the reaction MnO2 plus 4HCl turns into MnCl2 plus 2H2O plus Cl2. This was a question that was placed in the IIT admission test in the year of 1977. So let us do the sum. So the reaction is MnO2 plus 4HCl turns into MnCl2 plus 2H2O plus Cl2. This is given. Now let us find out the molecular weight of MnO2. That will be 55 plus 32, that equals to 87 gram. For HCl it is 4 into 36.5, and for chlorine it is 22.4 liter at NTP. That is normal temperature and pressure. Therefore, 1.78 liter of chlorine at STP, once again standard temperature and pressure all the same, will be produced from 87 into 1.78 by 22.4 gram, that equals to 6.913 gram of manganese dioxide MnO2. So for 6.913 gram of MnO2, the mass of pure HCl acid required will be this, just by simple calculation, 36.5 into 4 into 6.913 over 87, and that equals to 11.60 gram. But HCl is 40% pure, it is given in the question. That is, we require 11.60 into 100 by 40 gram, that is 28.69 gram of such HCl. Now, as specific gravity of HCl is given 1.12, therefore the volume of such acid required will be 28.69 upon the specific gravity 1.12, and that amounts to 25.89 milliliter, and that is your answer. So let us work out another question. A 1.00 gram sample of KClO3, potassium chlorate, was heated under such conditions that a part of it is decomposed according to the equation. The equation is given: 2 KClO3 turns into 2 KCl plus 3 O2, and the remaining underwent change according to the equation. 4 KClO3 turns into 3 KClO4 plus potassium perchlorate plus KCl. Now, if the amount of oxygen evolved is 146.8 milliliter at STP, then calculate the percentage by weight of KClO4 in the residue, given potassium 39.1, chlorine 35.5. So, this was a question that was set in the IIT admission test 1977. Let us solve. According to the equation 1, the weight of potassium chlorate KClO3 decomposed to produce 146.8 milliliter of oxygen at STP, that equals to this: 2 into 122.6 into 146.8 upon 3 into 22,400. Okay, that would be in the gram, you know. What do I get it? KClO3 is 39.1 plus 35.5 plus 48 sums up to 122.6, and that amounts to 0.5356 gram. The amount of KClO3 that was decomposed according to the equation 2, the rest, that is 1.00 minus this, and that equals to 0.4643 gram. Now, amount of KClO4 produced from this gram of KClO3 is equal to, once again, a simple calculation, 0.4643 into 3 into 138.6 upon 4 into 122.6. Now, what do I get this 138.6? This is the molecular mass of KClO4. Just you add it, 39.1 plus 35.5, and for 4 oxygen is 64, sums up to 138.6. Therefore, the amount of KCl produced from the reaction of 1 and 2, so this plus this, and that amounts to 0.3259 plus 0.0706, and sum it up, and that will become 0.3965 gram. Therefore, the total weight of the residue, what is the residue? The KCl and the KClO4. So, sum it up, and this becomes 0.7902 gram. Now, you know, in this residue of 0.7902 gram, the percentage of KClO4 you have to find out, that is the question. So, what that will be? It will be 0.3937 by this 0.7902, and because it's a percentage, you have to multiply this with 100, and that amounts to 49.82%. Now, the next question. In reaction, hydrogen gaseous state plus iodine gaseous state turns into 2HI, hydrogen iodide gaseous state. 0.10 mole of hydrogen and 0.20 mole of iodine react so that only 20% of hydrogen is transformed into hydrogen iodide. Okay? Calculate the weight of hydrogen iodide formed. I molecular atomic mass is given 127. This was a question from IIT admission test in the year of 1975. Now let's answer it. You know, out of the two reacting constituents, the lesser one can react completely, leaving the excess of the other reaction in the mixture. Accordingly, the number of moles of hydrogen consumed when 20% of it is transformed into hydrogen iodide equals to 0.1 into 20 by 100, that equals to 0.02. Okay. Now, according to the equation, the number of moles of hydrogen iodide formed therefrom is equal to 0.02 into 2, and that equals to 0.04. Now, molecular weight of HI, that will be hydrogen 1 and iodine 127, sum up together 128. So, the weight of hydrogen iodide formed is equal to 0.04, that is the mole, into 128 is the molecular mass, that equals to 5.12 gram. Now friend, at this end of the video session as regard to the topic, I want to continue this topic in the next video, but before that I must request you that if you are liking the content of the video, my request is that you please subscribe, share and like my channel.